Good afternoon, everyone. I think probably the one harder thing than getting through a conference in the afternoon after lunch and staying awake would be putting genetics in the topic. Thanks to Tom, he sort of got us going. And now, I have a bit of trouble with the term disruptive technology. I think the difference between whether a technology is an opportunity or disruptive is yes or no, and how long it takes to make the decision. Obviously, once that decision's been made, we talk about disruption to the current pipeline, and I think that they're really the challenges that confront us now with the speed of change that we see in our industry. So this morning, Richard Norton gave me the authority to come up with a date in which we could see a single species analysis, and I'd like to put out there that by the end of 2019, we could have a single species analysis running to start to get ourselves into a position so that Tom Bull doesn't buy all our farms. A single species analysis will reduce costs through less friction. It'll speed the rate of which technological developments can be commercialised. It'll simplify the result. It'll manage a nationwide output. I think it's something that we need to say yes to straight away. Single step needs phenotypes. I think that the challenge for single step is, and for genomic technology, is that we might get to the point where we feel that it's so cheap just to take a genomic test that we won't bother about going down and collecting the birth weight or other traits. So I think this is one of the disruptions which genomics is going to put into our industry, and I'd like to ask the panel, the first question is how we might confront this problem and change the value proposition of how information and genomics flow to give us a genetic result.
Okay, I'll give it a quick crack. And then throw to you guys. So that is the challenge that we're going to be confronted with, is it just gets so easy to take a tail hair or an ear punch. You get back accurate genomic breeding values. You can make a selection decision on a bull here and now. To maintain the accuracy that we have on our genomic breeding values, we just need those phenotypes to keep pouring in, really. If we just take what we have now and we stop recording phenotypes, I can tell you in 5 years, the accuracy of our genomic breeding values is going to pretty quickly get close to zero. So we need to set up a system where the phenotypes do keep coming in to maintain these reference populations. How do we do that? The best trick to pull off, if we can do it, and it's a big question mark there, is that people start recording data for management purposes, not genetic purposes. It's actually very hard to convince people to record stuff just so you can get an accurate genomic breeding value. Dairy is a really nice example. Farmers record milk production, fertility, temperament and so on, for management purposes, not for genetics. They do it to manage their cattle. And then the system is set up such that that goes into the genomic evaluations and we take advantage of that. So that would be the first thing to explore. Can we pull that off? And if you talk about DEXA and so on, getting lean meat yield information, that could be done just for management purposes. And then you take the DNA sample and that feeds into the genomic reference populations. Things like fertility, a little bit harder. There is a lot of pregnancy diagnosis and so on done. Can we feed that into the genomic analysis? The answer is probably yes. But we probably also need a greater level of recording than that. And we may be faced with a situation where we actually have to pay people per phenotype to keep some of that data coming in. Rob, do you want to elaborate?
I agree with everything Ben said, but I personally think we're going to have to think as an industry about what is the value of phenotypes and work out mechanisms for checking that if people go to the trouble of collecting good phenotypes and genotyping those animals, they are essentially getting recompensed in a reasonable way, because otherwise, exactly what Ben said, there'll be too many free riders, phenotyping will stop and we'll be worse off. I don't have a simple mechanism worked out for making sure that people are getting those returns, but we're working with MLA to explore some ideas with people like Ben and other people through the course of this year. But I personally think that is the single most important question about genomic technology. All the stuff that we've heard about, we know it's developing and it will work, but if we don't have a mechanism for making sure that we get good quality phenotypes in the right volumes on the right animals, and that the people who spend money to do it get those costs reasonably met, we'll be up shit creek basically. And that's going to require new organisational models, new relationships through the value chain, etc. Because just to kind of put it in context, at the moment people pay for phenotypes and they cover those costs in the bull sales, or they hope they do. So we rely on people like these two to collect a whole bunch of data and then sell rams or bulls, and hopefully they sell them for enough money to cover their costs. We've got to make sure that that is happening in the future if we want to use genomics.
Thank you, Rob. Question down here. Can you please state your name and organisation?
Charles Nason, commercial breeder. A question to Professor Hayes. The model I always use, that a rumen is a composite of two animals. The rumen, as you call it, the rumen microbiome, and the animal itself. In the figures you gave me, the microbiome was a better predictor than the genomic prediction of the animal in predicting performance. So therefore, do we need a separate EBV for the rumen as opposed to the animal, or a composite of the two?
Could you just repeat? Sorry, I had a hard time hearing that. But
Sorry, okay.
Could you repeat the question, Tom?
Well, I think it was, do we need an EBV for
Sorry,
the
okay, can you hear me now?
That's better.
Okay, sorry. To me, the model I've used on is a rumen is a composite of two animals. One, the rumen microbiome, and the animal itself. In the figures you gave me, or you gave there one example, the rumen microflora was a better predictor of feedlot performance than what the animal itself was. So therefore, do we need a separate EBV for the rumen as well as the animal? Or by making a composite EBV, we are not separating the difference between one animal and the other?
Yeah, that's a great question, and I struggle to answer it because I don't know what proportion of those differences in animals in their rumen microbiome is actually controlled by the animal's own genetics. So the great thing about EBVs is it's the part of the genetics of the animal, or the genetics of the animal that gets passed one generation to the next. So it is where your genetic gains come from. In the work we've done on rumen microbiomes, it's just how good is that animal's rumen microbiome that it carries around, its secondary genome, at predicting the trait. What we don't know is how much of that rumen microbiome is passed on to the next generation. And one thing that might happen is the way an animal's microbiome or a cow's microbiome gets established is when it's a calf, the mum just licks it, and so the mum's microbiome is passed on to the calf, and it sort of goes through the maternal line. But there's a lot more work to be done there. But what we're getting close to being able to do is, for an animal we have in front of us, being able to characterise its microbiome and make a prediction of how well it will perform based on that. But how much of it gets passed on, that's still research underway.
Well, on that basis then, until we understand that interaction, this whole day is going to be wasted.
I'll just get, we'll go to the back first, please. State your name and organisation. And there's another question down the front, if we can get a microphone down here.
Penny Schulz, Schulz Livestock in South Australia. Tom Gubbins, you actually put a good lead into my question around multi-breed EBVs. And my question was going to be, when do we think we might have multi-breed EBVs available? 2019 sounds pretty good, Tom. I'm just wondering whether that is actually a possibility, because it seems as though we have the capability, just missing some of the, most of the R&D. But when do you think that might be a possibility for producers?
If the question is when we'll get multi-breed EBVs, this is going to sound like a slightly wussy answer, but we already have them in tropical composites because they use data from several breeds. But in the sense that I think you're talking about it, we're involved in a project, a donor company project with ABRI, which the main breeds are supportive of, to actually trial making multi-breed EBVs, and I think that runs out by the end of next year. So I would anticipate seeing some R&D results for multi-breed prediction, possibly within British breeds and separately within tropical breeds, within the next 2 years. That's not the same as saying that's when it will become routinely widely available, because one of the purposes of the project is to let people look at it, see how they want to use it, see what data gaps there are. But I'll be very confident that there'll be multi-breed EBVs, at least in a research sense, inside this year and next year.
If I could add, the technology's already been developed. It's possible to do it. This is a cultural problem. It's old contracts that have been written in the past, pre-internet, pre-genomics, and it's a problem that we all need to take part in to make the change occur and support. Sorry, down here.
John Sprebrus, Angelini Wagyu. Just referencing, and this might be a comment rather than a question, but I'm interested if there's any response. Under the title Disruptive Technology and the Future of Genetics, it strikes me that we might have missed something that's really significant in terms of smart tags and the potential to address those difficult to measure traits, fertility, by detecting the cycle, detecting the pregnancy, and detecting the birth in terms of timing and scale. Any comment, please?
I think things like smart tags may well be the way to go. They just have to be demonstrated to work, and the threshold for working is actually pretty high for technology like that. It has to work 90% of the time. Otherwise, its value is, you wouldn't roll it out as a commercial product until you had it working a very substantial proportion of the time. And the research is going on, but it's not quite at that level yet, as I understand.
There's a couple of technologies being, in a sense, translated across from the dairy industry. It's not quite smart tags, but smart devices to collect data that will, it's phenotyping data for reproduction and possibly for other things. And I think I'm right in saying the cost is currently prohibitive for wide scale, but it would be fine for reference population animals. I think there's going to be an enormous number of new devices of one sort or another, and Ben's point, obviously, they've got to be highly reliable and reasonable price, but they'll be a really important part of us working out effectively what our reference population strategy is in Australia, because they'll determine what data we can get where on what animals, and if they make it easier, that's great.
So the other part, just to add to that, is a IT communications challenge. So if you've got a really big property in the north and those ear tags rely on a wireless transmission, all of a sudden you're up for the cost of putting in a whole bunch of collection towers around the place. Now that's shifting with things like new satellite technologies and so on. So probably those technologies will build on each other and come together to make something we can really use. But you have to have both those things lined up at once.
Down here, sorry, yes.
Thank you, Tom. That was a woohoo session. That was a ripper. Thanks, fellas. And talk about hybridisation. We've got a major plant breeder on the right, a super mathematician and genomics man in the middle, and a guy who just goes and does it on the left. And what a powerful team. I really salute you guys today. Now, I've got a question to Professor Hayes. Feed efficiency, there's a lot of argument about that and discussion, but my question was dairying, because dairying has always been the inspiration to me, because those guys, all my life, dairy people measured, so they are the people I look to for inspiration. And I'm so pleased you've cut your teeth in that field. Your feed efficiency, was that production of solids per kilogram of cow, or was it the kilograms of food taken to produce a kilogram of milk, or a kilogram of solids? Because there's a bit of fuzzy stuff there. Could you just tell us about that? How you, because if we can figure out kilograms produced per kilogram of ownership of animal and land, our two big costs, and make genomic gain there, we have really kicked a major goal. They're our huge investments. So I'm curious to just explore the possibilities there.
Yep.
I've done spreadsheets on dairy cows of kilograms produced per kilogram of cow, but I think it's a much bigger field than that, and I really would like your collective minds there to throw some light on that. Thank you.
So thanks, Al, for the question. The easiest way to think about what the trade is you have a kilogram of energy coming into the cow, and that gets split up into producing milk, protein, solids, and to maintaining the animal. The pathway to producing milk and the solids, that's a very, what would you call it, linear pathway. So the bit of energy that gets split off to do that, it's directly proportional, and there's not a lot of genetic variation in how much of that turns into protein and milk and so on. Where there is variation, though, is the bit of energy that gets split off into maintaining the animal. And there's quite a lot of variation there. And that's the bit, the component that we actually worked on. So in dairy, the genomic breeding value is called feed saved, and it's really the feed you save because that animal needs less kilos of feed just to maintain itself. Something else I want to add on the feed efficiency is the way it was pulled off in dairy was really to collaborate with other groups around the world. So because it's a hard trait to measure, you can only measure so many phenotypes in this country. We weren't getting high enough accuracies to put that out to industry as a genomic breeding value. So we teamed up with the Irish, the UK, and the Netherlands, all put our data together, and then we had high enough accuracies to say, look, this is something the industry can use.
Alec?
Alec McDonald, now Beef Central. A question for Tom Bull. Tom, when they did the first meat-sheep multi-breed analysis with whatever 14 breeds in it, I'd be pretty confident they hadn't done very much head-to-head comparisons to make sure that the relative EBVs for animals of different breeds was, particularly for maternal traits, was actually directly comparable. Was that a problem?
I'd actually say quite the opposite, because it was on the back of the terminal progeny test scheme, which happened in the 90s, Rob, and the maternal central progeny test scheme, which was probably the preceding 4 years, gave 91 sires, 11 breeds, Rob. a direct comparison head to head. That formed the basis of the maternals being able to flick the switch. And that was for milk, fertility, growth rate, muscle, it was all there. So there was probably a little bit easier for that reason. Certainly, you know, it's not all go on day one, it's not all perfect science, but I think it's a goal. And it's now, you know, we've had teething issues over the years, but I'm very confident to say it works extremely effectively now.
Perhaps that's one of the disruptions that we're going to have.
Tom, can I just say, I had a small part to play in that, and I wasn't in the business of putting dodgy shit out on the market for people. We tested it, I can assure you, and the industry had spent, as Tom said, a lot of money on structured comparisons involving multiple breeds and following their daughters through to get three joinings of the daughters of all these rams. So we had a really, wasn't the best base it could be, but it was a strong basis for that multi-breed comparison. We did not do it just because someone felt like it.
One more question. Last question.
Robert Wild. Just sort of trying to bring together a few topics from throughout the day. If eating quality is the ultimate consumer test, and if we assume that the MSA index is our best tool for measuring that, is it possible to have the MSA index as a trait and report on it as an EBV? It would bring together the value-based marketing and then EBVs, so commercial producers would be seeing the same numbers from both ends.
The research has been done to understand the genetics of MSA component traits and MSA index as traits, and they're heritable. We've got the parameters for 3 breeds based on the bin projects. The overwhelming message is that, at least in those breeds, MSA index and marbling EBV are extremely highly correlated. In fact, it's basically the same traits. So it's certainly possible to do it. If industry wants to change the name of a particular trait, that would be a fairly simple thing to do. But we do know the genetics of MSA traits in 3 breeds.
Thank you. Thank you to the panel today. I'd also like to say thank you to the scientists in our community, in our Australian beef and lamb industry, that do such a fantastic job to deliver. They sometimes get on the other end of a phone from a fairly disgruntled producer, and I'd like just to, in this forum right now, thank the science and the genetic community for delivering us such fantastic technologies. Thank you very much.